Okay, hello. We're going to go over some science jargon today and just kind of understanding the usefulness of science. My name is Cody Connor. Let's start with science. What's the definition of science? Well, according to the internet, first thing you pop up, science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. Yes, all very interesting, huh? Uh, so science is therefore studied empirically. Um, that keyword study, observation. That keyword of observation. Well, what is empirical? What's empiricism? Empiricism is the theory that all knowledge is derived from sense experience, stimulated by the rise of experimental science it developed in blah, 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 blah. You can read the rest of that if you really want to. Point is, pulled that definition off the internet as well. Okay, empiricism. It is, in general, it is defined as the process of acquiring knowledge through experience and observation. Empirical knowledge, therefore, would be knowledge that is based on the senses and the experiences of the world. So the things that you observe by your five senses: sight, hearing, taste, touch, smell, and so on. Okay. Empiricism and science. So what does this have to do with science? Well, as we said, science is done by observation, and empiricism is observing through your five senses. But what does that mean? Like, how do you do that together? How do you science? Well, empiricism is the central building block of how we do science. So, science through observation using the five senses and recording it. If you have ever watched Mythbusters, they said it's only ever science if you write it down. Science is described as a process of systematic gathering and evaluating empirical evidence to answer questions and ideas. So, in other words, we're gathering empirical evidence according to a particular plan that we've set up in the beginning, and then we evaluate it using some sort of reasoning in order to answer those questions and ideas. Like Dr. Horrible here. More empiricism in science. So, what does this have to do with science? Well, um, when we actively conduct research, we do not solely rely on empiricism, as it does have some limitations, which, with everything, there are issues. First of all, none of us experience everything in this world that there is to experience. That means that each of our own personal experiences differ as well as our own personal perceptions. Uh, so, again, like, you observe things and you record them, and that's your science, but your experiences and everything will always have something to do with that. So let's do some examples first here. Let's say uh, each of us did experience the exact same event, or how about we are looking at the exact same tree? So a tree such as this. Now there are two people that are looking at the same tree, but they're looking at it at different sides. The tree, as we can agree, is just one single tree, but it may be different on different sides. Obviously, it's not a symmetrical tree. Um, So even though they are viewing the same tree, they may not have the whole tree in mind. Thus, this is their perception. They are only perceiving one half of that tree. Kind of like thinking of two different sides of the coin. When you're looking at one, you're not seeing the other. But you know that there's more tree there than what you're seeing. Hopefully you know that anyway. This leads me to personal experiences. So personal experiences can also affect how we might perceive things. So let's break this down a little bit with our example. So we have this woman here. And then let's create some background experience for her. Let's say she's an environmentalist that has worked hard to inhibit the destruction of rainforests. So you see how she's on her cell phone. She's probably trying to save more trees. Good for her. Well, how does this experience affect how she perceives her side of the tree? And I did hit the question mark a little soon there, but that's cool. Well, she works hard to protect them, so she might be more inclined to notice things such as names that are carved into the tree, or perhaps axe or saw marks, maybe even animal marks. So her experience of dealing with trees and trying to protect them and preserve them make her more aware of things that might cause harm to trees. So whenever she looks at this tree, she might be more prone to focus on those aspects of it. And so that means that what she is perceiving is being influenced by her personal experience. The other guy, maybe he's a Boy Scout or something, and so he's looking at the moss, trying to figure out which direction to go. The point is, personal experiences will affect how we perceive things. Then there's this fun little thing known as the confirmation bias. That is totally sarcasm because it's not. It's not fun, even though most of us do this. Most of us fall into the confirmation bias. Well, got another fun definition off the internet here. Confirmation bias, the tendency to interpret new evidence as confirmation of one's existing beliefs or theories. So let's think about the tree again. Tree. This tree. Okay, so the way to think of it is this guy here is more likely to seek out others that share his view of the side of the tree. So like I said, maybe he's a Boy Scout. Maybe he's looking at the moss on the tree. Well, he's going to be more likely, whether he's intentionally doing it or not, to seek out others that will confirm that that's all there is to this tree, because that's all they see, this moss. Like this little guy here. He's only seen this one side of the tree as well, and can confirm everything that this guy saw, like with the moss. So they're sharing their experiences and also confirming what each other saw, thus reaffirming the idea that this is the only thing that you have for this tree, completely ignoring the potential for anything else that is on the other side of the tree. Now, what this suit guy should probably do is move to the other side of the tree and go and talk to the woman, this woman here. see what she sees. He'd find that there's a completely different side of the tree. Um, and kind of get a more full view of what it really is, what this tree really is. Hopefully that makes sense. Got my little invader sim there. All right, now what? What do we do now that we have such great and powerful knowledge on such a process? Well, let's talk about that. Science is used to explain things. We're going to go over, hopefully this example isn't too advanced. Try and make it as simple as possible. But we're going to go over decay effects by Peterson and Peterson, 1959. In this task, that is now referred to as the Brown-Peterson task, because some other guy, Brown, kind of came out with the same task about the same time. They didn't work together, but anyway, that doesn't matter. That's not the point. In this task, participants are presented with 3 letters and a number, just as you see here, the GTH 743. They had to remember these sets of letters, and they were given a number. Then they had to count back by 3s from that number that they were given. This was to help prevent rehearsal. Now, this was done through varying delays. And what the researchers found was that the greater the delay, the less numbers are remembered. So this rehearsal prevention method was supposed to demonstrate that you can only hold things for so long in your short-term memory. Short-term memory, for those that may not understand what it is, it's the things that you are initially processing. Think of it as like, well, exactly that. You're trying to remember like a phone number, something like that. I know most people don't have to do that nowadays. Type it in your little cell phone. But anyway, to continue with this, the Petersons found support for their claim by doing repeated trials. Now, this may very well be true that there is decay in short-term memory, but then, other people came along and they reanalyzed that exact same data, and they found that there was actually really decent recall after delays that were early in the experiment. Suggesting that the information is not necessarily decaying, but perhaps the information from repeated trials is making it difficult to recall in later trials. This implies interference as a cause for the short duration, not decay. This is interesting, right? Well, you may not think so, but that's not the point. The point here is to think about how, like the tree, you're looking at this from 2 different sides. And this is supposed to illustrate another point. But before I tell you exactly what that point is, let's move to my favorite phrase. My favorite phrase from undergrad, actually. The phrase that was used almost, it was practically daily in the psychology department in my undergrad. And that phrase is correlation does not equal causation. So you may know that there are ways to link cause in research, but that's not the point here. What this phrase is supposed to help you understand is that this is a good general rule for, like, just because you found support for what you're studying does not necessarily mean that it's fact. So why does this matter? My point. Uh, we're trying to get to addressing this word that so many people like to use when it comes to research, and that word is prove. Um, well, what does all of this mean in terms of proof? Well, everything. Because under no circumstances would you ever use this word prove in reporting research. And why do you think that's so? Well, think back to the tree. Well, you have this woman who has all this experience, sees all these cuts in the tree. She goes to talk to this man and says, well, I believe that someone has been trying to cut down these trees. Well, there's nothing on his side of the tree. He would argue and say, no, that's not true. But he would be wrong because he didn't see this clear evidence that was on the other side of the tree. So, with the memory example, the first researchers thought that they may have found proof for decay, but using that same data, it was shown that it could be something else too. So, proof tends to indicate that there is no room for change or to change or adapt and grow. There is also the other issues that we discussed that is inherent in empiricism. So, another point on not using the word prove in research. It leads to this idea that you found the end-all be-all answer to whatever question that led you to do the research in the first place. So, as I just stated, it does not allow for change or adaptability, which isn't the point of science. While you may think that you have found that end-all be-all answer, all it takes is just a single case, just one, against your answer to demonstrate that it doesn't actually prove anything. So that's why we reject the null rather than prove our research hypothesis. And we'll go over those in a later video, what a research hypothesis is, and a little more in depth. But we're going to review what's the research hypothesis, or the null hypothesis. The null hypothesis usually refers to a general statement or default position that there is no relationship between the measured phenomena. Basically, it assumes that there is no difference among groups. So by saying we reject the null, we are saying that we have support that there is a difference. So the null, let's apply it to the tree. Our null hypothesis might be that there is no difference between the sides. But when in fact we can reject that null because we know there's differences on the sides. One of the sides has a bunch of axe marks on the side. Side with a woman. Okay? So we're going to recap here just a little bit. That'll be about it. Science is good. Use it for greatness. But with great power comes great responsibility. So what do I mean by that? Never say prove in research. We simply reject the null hypothesis. We just find support for our own research ideas. I will elaborate more on another video on what a hypothesis is, as well as a theory. You may see some of the same concepts presented in that next video. Thanks for watching.